Yeah, welcome to the MS-22 workshop. Super cool filter. I tried it this morning and a couple of days ago, and I was really surprised how well it sounds, how clean it can sound, how aggressive it can sound. Yeah, Tom himself is also here. Welcome, Tom.
Hey, Manu, how are you?
Hey, hi. I can see you a little bit on Dean's monitor. So where are you at the moment? In your lab?
I'm at home in my lab, in my very tiny lab. I'll show a picture later so people can get an idea of what's in here and just how tiny it is. Perhaps while we're waiting, I can test something and I can give perhaps people a filter sweep. Let's see if that works.
Yeah.
Okay, that's good to know. Then I need to throw an extra switch on my little mixer here.
Yeah, Tom, thanks for joining us. That's very nice. You just tell us a little bit about the filter, how you came up with the thing, with the idea. What is it about? How did you cram all the shit into 4 HP?
With lots and lots of patience.
Yeah, with 4 layers, 4 stacks. Yeah.
Yeah, sure. I've made a little presentation, so if we can switch to that. Okay, there we go.
Very good.
So, first of all, perhaps let me tell you a little bit about myself, just so you get a bit of a feeling of who I am. So,
yeah, who are you? Where do you come from?
So I'm Tom. I am Belgian. I live in Belgium, somewhere right in the middle between Antwerp and Brussels.
Mm-hmm.
And so my background is an engineering background. I have a bit of a literal and figuratively broad profile. So I have backgrounds in electronics, optics, and then also some mechanical engineering that I've picked up along the way.
Mm-hmm.
And so as a day job, I'm an R&D engineer / maker. So I build all kinds of cool and fancy projects like proof of concept setups, demonstrator setups. Basically I get paid to do my hobby, so that's really nice.
Yeah, that's good.
Yeah. So what else is nice to know is I'm a coffee lover. I have a big espresso machine in my home. I'm a bit of an amateur barista. It's actually surprising. So on my online shop, I added this little product called Buy Tom a Coffee for €1.
Yeah.
And I thought, nobody's ever going to use this. Originally, I just added it to test the shop with, to pay by credit card and see what happens. Yeah. And I left it on there kind of as a joke, but it's really surprising how many people have bought me coffee over the last year. It's really heartwarming. So to everybody who has bought me coffee over, well, since ever, thank you. Thanks a lot. I really appreciate it. Yeah, so what else is there to tell? I'm a bit of a bass player. So I did go to school for 3 years for double bass. Does that mean I can actually play it? Well, no. I can hold it.
We can open a band. I'm a drummer.
That's good to know. And then finally, I will confess that I am a total synth culture barbarian, which may surprise a lot of people. So I've made a filter that's inspired by the MS-20, but I've never in my life heard the real MS-20. I mainly focus on analog, on innovative modules. So I don't want to make anything that's out there already, because I'm sure what's out there already, the guys that are making that can do it at a much better price point and at a much bigger scale than I can, so it's not worth bothering.
So if you make a filter, you want to make a different filter with different features.
Yeah, it has to be unique.
Yeah. Okay.
So Threetom still is a hobby that got out of hand for me. So I still have a day job, and I do want to keep it that way. Actually, it's very nice that my ability to eat a sandwich at the end of the day does not depend on Threetom.
Yeah.
And so
it takes the pressure off.
Yeah, so I can do whatever. I can come up with whatever without fear of having an impact on my income, which I hope will result in nice little products. So here's to answer your question. This is what my lab looks like when it's cleaned up.
Yeah,
that's a very rare state, as you may know. A lab usually isn't this cleaned up. The instrument rack here that has also since filled up a little bit more, and this is now full of crap. You know how it is with labs. And so, as I said, it's only 2 by 2 meters, so super cozy. And then, of course, I don't solder here. I used to in the past, but it's really not doable with all the extra equipment that I've got.
So you have a different place for this?
Yeah, so that I do out of my garage. A lot of people ask me who the bleep is Steve. So that's part of the story that I like to tell. So Steve here is a guy that I met on Facebook somewhere early 2019. Back then he was still a tech journalist for TechCrunch.
Yeah.
And now he's VP at a startup delivering groceries, I believe. And he also produces blues records under the Nomer Otis Max Load. So look that up. It's I actually have the vinyl record that he produced. It's quite nice. And so, how did we first meet? Steve was looking for somebody to build him a DIY kit for an MS-20 filter. I believe it was the AI synthesis one. And back then, I had been building some kits, and I was still exploring, like, do I really want to do something more with this or not? And we started talking. I proposed him, perhaps I can build that kit for you. And as we talked, Steve told me that he has some more ergonomical constraints than the average person. And so as a result of that, he only could have a very small rack, so 84 HP, let's say.
Yeah.
And of course, he wanted to cram as much in there as possible. So he told me in an ideal world, I would have this filter, but half the size, so 4 HP. And that kind of triggered me thinking like, that sounds like a challenge. So that sounds like fun. Perhaps I could do that because, in my day job, I do design PCBs and stuff. So at least that part isn't really a challenge. And so I should be able to do that. And then somewhere end of 2019, the first final version shipped over to Steve. And then beginning of February last year, I started business as a sole trader.
Yeah.
Also, by the way, worth noting, so Steve's MS-22 isn't the only module that Steve inspired. He recently also collaborated with Takab, making VCO's Little Helper, which is a very small ring modulator and sub-octaver. So you can put in 2 VCOs on the top, then you get out the ring modulation, a sub-octave. The idea behind the MS-22 when I started the project was impress or go home. And so, as I said, I didn't want to do anything that's already out there. There's plenty of single 4HP filters out there. And so basically what Steve wanted was a single low-pass MS-20 filter in 4HP. And I said, yeah, that's not challenging enough, not sexy enough.
I want to have some fun.
So I kind of upgraded the requirements to make it a bit more interesting. And so what I defined as my requirements were, okay, 4HP wide, not one filter, but two filters, both low pass and high pass. Also, the order is different than in the original MS-20. So in MS-22, low pass goes into the high pass. In the original MS-20, that's the other way around. I will claim it is intentionally, and it is not the consequence of me not knowing shit about the original MS-20.
Yeah.
So what's also different is that you have CV control over everything through a nifty little mod matrix.
Yeah,
and there's
very good.
Yeah,
I tried it. It's good.
It's cool. It's fun.
Very practical. First, I really thought, oh man, this is somehow strange, because at first you have to deal with these two cutoff frequencies and how they work together, and with the switch and so on, and then you need to play with these a little bit, and then it really becomes your friend.
Yeah, my experience is I'm going to show the block schematic in the next slides.
Yeah.
And I agree. On paper, it looks too complex.
I thought the same,
yeah.
But it's not. And once you understood it, it's fine.
Yeah, you start playing with it and you get a feeling for it, and then it becomes second nature. And so then finally, another cool and unique feature is the gain staging. I'll show that in the block schematic, but basically there's VCAs in between the filter stages. So as you turn the gain knob, these VCAs get more gain. And so that results in smoother gain staging. Instead of you blasting the first filter in line, a low pass filter, then distorting that majorly and then feeding that distorted signal into a high pass filter. I like to think the result is smoother. And so, of course, to get all of that into 4HP, that resulted in a tasty 4-layer PCB sandwich.
Yeah, the stack.
So to give you an idea, there's 9 quad op-amps in there, so 28 op-amps. 4 LM13700s, so that's 8 OTAs, 8 VCAs basically.
Then let's move on a little bit, that we start building soon.
So I'll just briefly walk through the topology, and then we can start we can get to the building part.
Yeah, super.
So as I said, there's the input, there's a VCA of the gain staging system. That goes into the low pass filter. Then here there's a feedback circuit also with the VCA and clipping diodes. So this is the resonance circuit basically, that's voltage controlled. Then it goes into another VCA, into the high pass filter. And there you have a similar resonance circuit too.
And the gain knob is controlling both gains at one time.
Yes, and so the resonance CV also controls the resonance of both filters at the same time.
Yeah.
And then those blue lines, those are CV, and those get routed through the modulation matrix. And so there's basically the FCV, that's the CV for the low pass filter, the frequency CV, goes through an attenuator, and it's added, that attenuated CV signal is added to the front panel control. Then the sum of that CV goes to the low pass filter. Then there's also an auxiliary CV, so ACV short. It's normal to the first, to the FCV, similar attenuator. And then there's also an inverter. So the attenuated aux CV, internally we have a positive and negative polarity version of that. And then there's the switches that are next to the front panel controls. So you can add the aux CV either inverted or either positive to any of the parameters. And then for the high pass filter cutoff, you can also add a portion of the low pass control, so that you form a band pass filter.
Yeah.
So there's still lots of info on this further in the manual or on the website. So if you want to know more, go check out my website. There's also links to social media, how to contact me, etc. And then now I guess it's soldering time.
Yeah. Thanks, Tom. Thanks for being here.
Yeah, my pleasure.
Cool. Yeah, then we start soldering. Andreas is on the soldering place.
Hello everyone, I'm Andy. I'm the soldering guy. You can't see me right now, but I will solder the module.
We start by taking out the PCB. It's paneled up on this PCB frame. So one of the first things is we should identify which is what. The most right one is called PCBA, and then to the left B, C, and D. On C and D, you have the trimmers, which you have to adjust for the calibration later. One of the first things we do is, I would say, we add the headers, which connect the sandwich together then. So, and you start with these headers. There are female headers and male headers, and they connect the stack layers together in the end. There is one bigger one. This is the power header, where the ribbon cable for the plus and minus 12 volt and ground comes from the bus board. And we have some smaller ones. We have these 10-pin headers, female and male. Then we have some 20-pin headers. And I would say we start with the 10-pin female headers.
So the first goes to the PCB-D.
Yeah, PCB. The good idea is to put it in place, then turn it over. I mean, you could also put all the headers in place and then turn it over. But the thing is, once they are not aligned with the PCB in a 90-degree angle, then it's very, very difficult to correct this. So a good idea is to put it on the back then.
So I messed it already up.
A good thing now with these headers is when you start with one pin first. Maybe you can start, Andy.
Yeah.
Yeah.
I will solder one first leg.
Yeah. You take one edge, one corner of the connector. So first you always heat up the component leg and the copper of the PCB with the iron. Then you put your solder into place, then it melts, you take the solder away, and then in the end you take the iron away. So, and then you can turn the PCB over to the other side and can check if everything is really aligned and sits properly on the PCB. Because this is important, otherwise it won't fit in the end. So if you manage these, then you can take the other corner, diagonal on the other side. Then you have 2 points, one on each side of the header. And the thing won't fall out, everything will be fine. And if you have this, then you can do all the other points. I mean, with these DIY kit, and also the one we did last time, the Transient 4R, space is an issue, and there you really need a small soldering tip, handle style tip, not the screwdriver type.
Yeah, the key is not to use too much solder.
Yeah.
then it will give a connection to other
Yeah, then you
points.
get short circuits and okay.
So yeah.
If you have this, you can check your solder joints. If they look like bubbles, this is not the best thing then. Yeah, very good. Okay, Andy takes the next. It's also a 10-pin header.
A good tip is to turn around your PCB with the pin headers. They don't can't fall out. Take Tom's great card, hold it, flip it around.
Yeah, put it on the back. Yeah, and then do the same thing again. First one corner, one leg on the corner. Then turn it over. Check if it's really sitting on the PCB. Turn it over again. Do the opposite side, and then it can't move anymore. Very nice. Yeah. If you have the feeling that one solder joint is not properly done, like there's too less solder or there's a bubble or something, a good idea is to heat it up again. Mostly it's only an issue of heat transfer. So, and heat transfer is coming by a clear decision. Yes, I want to solder this thing now. Put the iron in place. Mostly it's an issue of heat transfer. So if you heat up the solder joint again, then mostly the solder will melt and go into place. If not, you can add a tiny little bit of fresh solder, because then also new flux will come into the place and will smooth it a little bit. Yeah.
I will continue to the next.
Yeah,
to
the next one. This is the big
header.
one. Female header, 20 pin. 20 connections in one. Yeah, you can use the card. Put it on top, flip it around. And same procedure. First one corner. You heat up one leg and the solder pad at the same time. Add some fresh solder.
Does the higher temperature also help with make better connections?
Yes and no. I mean, heat transfer is the key to a good solder joint, but if you solder too long and too hot, it also can, first it burns the flux, then it gets black and so, looks shitty. That's normally not the biggest issue. When you redo a solder joint often like 3-4 times, or you really have problems and have to debug your module and so, then sometimes it can happen that too much heat lifts off the copper trace from the PCB material, and this is an issue. Then it gets really complicated. Or same thing happens when you have to get off stuff like these pin headers, which have a lot of connectors, and you have to heat them up at the same time and then get them out. You have to pull a lot, and this is not very healthy. Then the problem starts.
So I'm ready for the first male header. I hope everybody else is, same position right now. Same thing again. quite okay. So I'm done right now. I will wait for Manu. He's checking the chat.
Trying to solve problems.
So to get the view, my solder iron is about 380 degrees right now. When I solder pin headers and stuff like that, or I know there's a big ground plane which will have
absorb the heat.
I do it very hot, mostly fast to the end or so. And
but someone asked here, he's using temperature around 250 degrees. So this is super low. I mean, it also depends on the solder which you use.
Sure,
really different solders, but I don't know. This is really very low.
350?
250.
250.
250.
So 250 is really, really low. If you use leaded solder, could
old
be
school
okay,
style.
But yeah.
Okay.
Next step is to turn it around, yeah?
Then we work from the other side, which is the male headers then. 3 male headers. The bigger one is the power header. We do this last, I would say. Let's start with the small ones, the 2 10-pin headers, and the same procedure. Put it in place, turn it around, do one corner.
Oh, what's wrong?
Yeah, sometimes it turns off automatically, huh?
Yeah, I don't know why.
Ja.
Jetzt doch mal die große Welle mitgenommen.
Who knows? Yeah, do one first, turn it around and check if it sits well aligned with the PCB. And if yes, do the opposite side. And always when you have, in terms of these pin headers, it's quite dense, and you have the next solder joint is always very near to the latest one. And what you should do in this case is you should come with your iron from the side where the solder can flow to. Means you come from this side where you don't have any connections which are very close to that one, because the solder always flows to that point, which is the hottest point. And if you solder from in between 2 legs, you might make a connection between them. If you come from the outside, it's better. How do you do it at the moment, Andy? I will have a look.
I go from one side to the pin and go a little bit further and come from the right
between,
side.
huh?
Yeah.
Yeah. Yeah, good. I mean,
yeah,
you know what you're doing.
That's how I started. So yeah, old habits. Huh? All right. So this is a little bit tricky here with the trimmer in between.
Oh yes. Close to the trimmer.
All right.
Good. Let's
Always
see.
check it. So yeah, the last one between the trimmer, I missed a little bit. I will do it again. It was not perfect. So yeah, that looks good.
Yeah, maybe you can show this to the camera, Andy. How it looks like. Okay. Then the next one, huh?
The pin header, the power header.
The power header. Yeah, the big one now.
Okay, the same thing. Check your first solder point, turn it around. If it's flat to the PCB, that's what you want. And then do it on the opposite side. So you can do the rest. So here will it absorb many heat because it's the ground in the middle.
Yeah.
So it needs some time. So I will do one again. So we are ready with the pin headers. What do we have on the next step?
Yeah, the next is we have to unpanel the PCBs.
Some mechanical stuff.
You need the wire cutter now. If you don't have a wire cutter, I would use a flat pliers, I would say. And then break these small areas around, like the frame, break the frame away with the small pliers. But if you have a wire cutter, I would use this, like Andy will do now.
So,
I mean, I oftentimes, when I had these kind of panel things where all the PCBs were one thing and together, I just used my pliers, the normal pliers, flat nose pliers, and break it off.
So I'm in picture right now? Yeah?
Yes.
Okay.
Yeah. So there possibly you have to be a little bit careful because these cheapo wire cutters, sometimes they break.
So
If you do things where they're not made for. This is the only one we have.
So it's easier to cut from the side.
Yeah, not to do it too flat, huh?
Okay, let's do the outside first.
Yeah.
I will try it like in the manual from above, but that's much harder. So from the side, I think it's the best way a little bit.
Yeah. Would do the same.
Carefully. So now we cut the extra, which I used as a keychain.
Yeah, possibly you should cut off all the rests as much as possible. And you can use a file or sandpaper. Or if you have a sound box, you can use your sound box for this. There's sandpaper on it.
Scratch on the sound box. Plug it in first so you can record some
it.
Crazy sounds. All right. Just a little bit, but not too much.
Yeah.
So
basically to remove the very sharp edges, and then it's enough.
Will be not be in 4.5 HP module.
Once it's running and it's in the rack, then
nobody will see it. Yeah. Okay, so we have still PCB A. Where's B? I think that was B.
Do you still have the marks on it, or are they gone?
They're gone. Only A.
Okay.
Survived.
Yeah, good. But we start with A anyway, as far as I know. Because the first thing we have to do now is to use the two M2.5 screws, which are included in the back with all the components. And you take PCB A. Oops. And there are two holes. Both are under the pots, right?
Yeah, where the silk screen is.
Yeah. You see a big hole there? Yeah. That's the place where the screws come in. From the side of the silk screen, can you turn it around, Andy? So that we see it from the other side. So not from this, yeah, from the other side. Where you place the potentiometers later. Possibly you can put something, because now we have the pin header. Yeah, right. Now we have the pin header and the PCB doesn't lie flat on the table. So you have to maybe to arrange something that it doesn't wobble around too much.
And also the screw.
And now you possibly need a quite longer duration, soldering duration. And at this point, a good temperature.
Manu, you can add the screw on the, you can add the nut on the screw to keep it in place. It's not in the build guide, but that helps a lot if you don't have a vise to keep it off the table.
Yeah, right.
That's a good idea, yeah.
Good idea. Let's do this.
And the key is to be patient, because that little nut has a lot of heat capacitance.
Yeah. Yeah, it's the same like when you have a big ground plane. It just sucks away all your heat.
Exactly.
Good is just to heat it up. Put your soldering iron from the side, so you heat up the ring and the screw. Maybe use a little bit of solder, because then you have a better heat transfer. And just wait and heat. heat up. Add a little bit of solder here and there. And then you will see when it melts.
So if you have, for whoever has a hot air station, this also works great with hot air and solder paste. And if I produce the assembled modules, I use that method.
Yeah, of course. If you have such a one, that's very good.
So now it's get melty, but I also messed up the first potentiometer hole.
Yeah, okay. Yeah, then we can show the trick with the pump.
So,
do you know the percussive desoldering method?
What? The percussive method? Which one?
You don't know the percussive desoldering method?
Nee.
This hole is excellent to demonstrate. Basically, what you do is
I have an idea.
Heat it up, and then you gently tap the PCB on the table, and it shoots out.
Yeah.
Because of the momentum.
Yeah. Yeah, I did this before, and also heat it up and just blow it free.
Yeah.
That I've never tried.
Yeah.
I will give it a try. I never tried this before.
Yeah, try the percussive method.
I hear if you're really brave, you can suck it out yourself.
Yeah, okay.
I can tell you something. At this point, for this method, it's good to be a drummer, because then you train this movement to gain the maximum momentum from this.
Okay. I have to say it works. Okay.
Yeah?
Yeah.
Good. Yeah, then just take the next screw.
So.
Yeah, I see in Tom's build guide, he has written 350 degrees on the iron, or 165 degree hot air.
It really depends a bit on the iron that you have.
Yeah.
So
and also the solder or the paste, huh?
Yes. So typically lead-free solder, and that you need a little higher temperature for. And it also depends a bit on the type of your soldering tip. So the soldering stations on the lower price range, they have to call this passive tips, indirect tips. So the temperature sensor and the heating element are actually located rather far away from the tip.
Yeah.
And so because of that, you get a temperature gradient from where the actual heating element is towards the tip. And to compensate for this, you need to set the iron higher than your intended soldering temperature.
Yeah.
And so with these passive tips at 350 degrees, 380 degrees for leaded solder is not that uncommon or crazy, actually.
Also the super cheapo irons, they have the hottest point then not at the tip directly, then a bit behind it. Then there are always these bubbles. I mean, maybe you experienced this in the past somewhere before you went.
I can show you. It so happens I still have my old Weller here.
The blue one.
Whoops. Yeah, so my camera won't focus this very well. It's set on manual. But this is a perfect example of a passive tip. It's this kind of soldering tip where you have this flat end, and then somehow you screw the tip onto it. And then the active tips, you'll see this more kind of plug and play system where the sensor and the heating element are right at the very tip of the soldering tip.
Yeah.
And that really makes a lot of difference, because I only replaced this guy a little bit over a year, I think. And now that I have an active tip system, I usually solder lead-free at 325 degrees, and that works like a charm. Yeah. But that's just because the temperature gradient isn't there. And so if you put this guy at 350, chances are that at the tip it's 325. And so it's all relative.
Good. So, Andy, do you have it?
Yeah.
Ready?
So I'm ready. It holds together. That's the point.
Good. Very nice. In the next step, we'll do the potentiometers, the switches, and the thonkicons. One potentiometer is different from the other ones. You have to separate this first. One is a 50K. So one is a 50K. And the others are B 50K. B is linear. And A.
Yeah, you can see it on the back side of the potentiometer.
Yeah, there's something written.
Oops.
I have this over here.
Ah, yeah. There's the picture. One is different from the other ones. And first, from the top is there where you have the switches. Switches are on the left side of the potentiometers. The first three potentiometers are B50K, then you have the A50K, and then another two B50K. You put them in place. And really make sure that the A50K is the fourth one from the top. Because if you have to change this afterwards, it's possible. And in case of potentiometers, it's still quite easy because you only have 3 or 5 if you count the solder lugs on the right and left side contacts. But if you have to take off the big headers and this kind of stuff, that's really a hell if you have no hot air. Okay, and then after this you can take the switches.
I will put the washers on first.
Yeah, okay.
I think that will be easier.
Yeah, we need the washers. Then the switches. And the switches, these should be normal SPDT on, so means they don't have any polarity or whatever. All should be the same.
All right.
Now it gets tricky. And then the black audio connectors. They have this one pin which goes to the side. 2 of these face downwards, and in the lower row they face upwards towards the other. And possibly they go in the same hole, right?
Yeah, they uses the same hole.
Yeah. Okay. Then in the next step, we need the panel. The front panel. It should have. Yeah, it's good if you have prepared it. And now it's a bit tricky.
If you're having trouble getting the thonkicons through the panel, if you have like tweezers lying around or a screwdriver, it's handy to poke at the thonkicons to get them through the hole.
Yeah, Andy managed it. We do this because that's a good trick in general to do it. I mean, you can solder all these components individually, and just hold one component at a time, flip it over, solder it, and so. But the thing is, if they are not absolutely aligned, the more components you have on your PCB, the more difficult it is to get the panel on. If you have a module with 25 jacks or so, and they are not absolutely aligned, it will be impossible to attach the panel later. So that's the trick. You do it first.
That's what happened to me with the hacked mix.
Yeah.
Yeah. I
Yeah, it's
soldered
crazy
it
big.
Okay, it will be fine. And then I used the panel and said, oh shit.
Advanced project.
Yeah.
Yeah. So you do this, then you put the nuts on.
Start with the funkies.
Mm-hmm.
So.
And you don't have to tighten them up so crazy. Just loosely, that everything stays in place. And then the switches are held by the panel.
So Domestic Scene Music is asking in the chat about soldering the clip supports on the potentiometers. So it's not strictly necessary and they're not grounded, but I like to solder them in any case because they do add to how firm the front panel controls feel. Because if you're twisting them hard, let's say, and you don't solder these clips, that strain will end up on the connection pins of the potentiometers. And so if you solder these clips, and then most of that goes into those clips.
You have a mechanical hold.
Yeah,
that's right. Yeah, I mean, especially you don't have any other possibilities on this small board. There's no screws, nothing else which holds anything.
Exactly.
Yeah, Domestic Scene Music. Hey, hello. Welcome to the live stream. He knows about videos. He's doing videos about sessions, live sessions he does, and he has an own YouTube channel, Domestic Scene Music. He's doing this kind of videos, but not live. More in a studio surrounding. Very nice videos. He did some build videos for us. Some are in the making actually right now.
I'm checking it out as we speak.
Yeah. Yeah. Yeah, we found him on the web, and he has a nice attitude. Nice, friendly attitude.
I will subscribe and binge watch later.
Yes.
All right.
Yeah, Andy's ready. Yeah, then we have to solder all these.
So.
Potentiometers, switches, etc. Yeah, now
I use Tom's tip to use the cutter to hold it flat. And then you can go on and solder all the joints from potentiometers and jacks and so on.
Now this should be easy because there you have much more space than at these pin headers. Should be easy.
You don't have to control if they're completely flat.
Now everything is held now by the panel. Pushed down by the panel.
So I will do one group of components after and after.
Switches first or what?
Yeah.
Hey Tom, nice switches by the way. What's this brand? Manu. The connection between Befaco and Exploding Shed. Befaco's Manu is also, his name is Manu, My name is Manu. That was funny when we met. And we started in 2016. Befaco's modules were one of the first we distributed. So, and then we met a couple of times at Superbooth, and we went to their modular day, which they did in Barcelona 2 times. Hagen went there. I didn't went there. And yeah, we met in Berlin at Superbooth and so, and we're emailing, and we have a good business relationship, I think. But also there's in the whole modular area and this DIY scene and so, it's more than just business also. It's we just like them as humans. And I think they do such an incredible job. I mean, when you do 1 good module, it's nice. When you do 5 good modules, it starts really becoming big work. And they do so much. They work so hard. It's insane. And they put all the effort in DIY still, while other manufacturers actually move at the moment away from DIY a little bit, because they professionalize themselves. The whole scene professionalized a little bit. Some manufacturers, like we too, we have these pick and place machines where we can work with SMT components and do it automatically and so. And that's the point where some small manufacturers decide to leave the DIY route, or actually basically to leave the DIY route, because DIY, oftentimes it's more work than just manufacturing stuff and selling it. And Befaco do it differently. They really push full on DIY, and that's so good.
Yeah, I actually appreciate the DIY community is a nice club of people, and
Yeah.
I must say that indeed there is some support involved, and so I do end up helping people out, which I don't mind. But
it needs time.
I will admit that sometimes, let's say, I've just you guys release a batch of kits, and then it can get busy for a week or 2, replying to everyone.
Yeah.
But yeah, I do get a lot of appreciation for that, and that does make up for it, I feel.
Yeah.
Yeah. And by the way, Manu, those switchers are from Dailywell.
Ah. Yeah, they are nice.
You can also get them at Farnell sometimes. Then you don't have a lead time.
As an engineer, I really like the trimmer.
Yeah, the trimmers are good.
Yeah, that's what I want.
Small, but good.
Yeah, they're very nice, but they're not cheap, unfortunately.
Yeah.
And they're already knockoffs from Borns. So these are made by Nidek Koppel, and they're basically a knockoff of the Borns trimmers. Can't recall the model number, but yeah.
Yeah, I tried them while calibrating, and they go very smooth and everything. It's very good. In the next step, we need the LEDs then, and we need port B.
You'll also need the nuts and 2 standoffs.
Andy, I think you have to remove. Nee. Do we have to remove the nuts from board A now, or?
No, you'll need them.
No, they stay on.
I moved it, but I see that I have to rearrange it.
So, yeah, maybe if you don't have the right tool for it, you can use the pliers like these. Do we have these pliers there, Andy?
Yeah, 1 second.
Because now, hopefully, this is the final assembly of this stage.
Don't over-tighten them.
Nee.
You can still, when you add the standoffs, They will also tighten the nuts a little bit further anyhow.
Yeah. Then we need the standoffs. Yeah, this one's.
You're all the same, yeah?
I think so.
Yes.
They go on there. Okay. So far, so good. Then we need board B. And this is the one without any trimmers. There are two of these big gray blocks, let's say, on two of the other boards. These are the last ones then. You also see the silk screen print for the LEDs. It's 4 of these white prints, like circles or half circles. Yeah. And then you have to place the LEDs.
So they're different lengths. So the long one is positive and has to fit on the...
There's one squared pad and one round pad. And as far as I see, the long one goes into the squared pad.
So it's on the outside from the PCB.
Towards the edge of the PCB. And it's the same for all 4, right? Yes.
Can you show it with the last one?
So here's the long leg.
Long goes to the square solder pad. Yeah, and then first just put it in. And then in the next step, you have to sandwich the first 2 layers together. And you have to take care that the LEDs don't fall out. And then maybe
Okay, I get the point. I have to do it again because I can't get the LEDs over the next PCB or PCBA.
you have to put it in these.
So carefully pull it apart. Sometimes it's bent. So
you have to pull them a bit, push them a bit through. So
yeah, I ended up designing it this way because there was no more space for more connector pins.
Yeah, of course. I mean, you crammed a lot of functionality into this. I really like the thing with the LEDs, I must say. It's very intuitive. You know where you stand, When they go off, I'm at 12 o'clock. It's super nice. It's a good interface to work with.
Thanks.
Really like this. Yeah, okay. And when you managed this, just push them through the panel, I would say.
It's best to fasten the nuts before soldering the LEDs so that you don't create any strain on them.
Yeah, okay. Then use some nuts or the next standoffs or something. Do we have more nuts?
Yeah, the next nut.
Oops.
You have to find a possibility to place the PCB stack somehow that it doesn't fall to the side. This is tricky now, huh?
Yeah.
Hey, maybe you can use the roll of solder and to lean it against it. Yeah, somehow like this. And then you have to make sure the LEDs really go through the panel all the way through, because nothing looks shittier than when one LED doesn't look through the panel properly and the others do.
Or on the same place like the other, yeah.
Just not nice.
All right, so I will solder one pad first.
Mm-hmm.
I do it on all four, so I just have to turn it once time around. Okay, and have a look. Looks perfect.
I mean, moving LEDs forth and back is still quite easy because you have only two legs, two solder joints. I mean, if we are too fast or so for somebody, you can watch this video again later, of course, and then there's the awesome build guide, the original build guide, the PDF by Tom, and there's a good video by Synth DIY Guy.
So the next step is for me to cut up the pins from the LEDs.
Mm-hmm. So someone has problems with a pin header.
Hey there, Jack. You guys know Jack Edwards?
No.
AKA Mono Jack Edwards?
Nee.
He runs a repair shop over Elevator Sound in Bristol.
Okay. I heard from him.
Yeah, it's he started that shop from almost nothing, I believe, and it's kind of neat to see how he built his business over the last year, I believe.
Mm-hmm.
So yeah, I'm a fan. I follow.
Cool. Yeah, then you have to cut off the legs, and then we add the next layer.
Layer C is...
Yeah, which one is C? Which one is D?
C has one female and one male header on one on the other side.
Oh, yeah.
So, and the last PCB...
Only one fits, yeah. Right.
It's Tom hats and sunglasses.
So first you have to put the nuts on it, tighten them a bit, then put the standoffs onto it. Andy, the standoff. Next standoff.
Aha. You got me.
We have some nice noise from the microphone again.
Pink noise.
Yeah. Pullman will get a package from us with 2 microphones because I don't want this shit anymore.
It's the second time.
Fuck it. I mean, we bought it half a year ago or over half a year ago, but I don't care, man. I sent the Scheiße back.
I got a headset from them a while ago, a few months back, a Bayer Dynamic, and the microphone on that was dead on arrival. It was so crackly, unbelievable.
No, we have Sennheiser.
Even the better ones.
Yeah, it's no cheaper ones. So you push this on. So C is on now.
C is on.
Cool. I mean, yeah, now it goes fast, huh? Then you have to attach the nuts, tighten them a bit, and then the next standoffs again.
So, Tom, what are the last washers for?
You mean
I think I missed them on the Funkies.
Yeah. Audio
The
jacks,
small ones.
yeah, those are just not to scratch your panel when you turn them on, but
Okay.
it's not the end of the world that you're missing them.
Super professional.
Yeah, I haven't seen washers for audio checks before.
Yeah, they do exist.
Yeah, most leave them away.
What are you telling me, that I'm delivering too much?
Yeah. Too much stuff for the money.
Time to cut costs. These cost almost next to nothing, these washers, compared to the checks themselves. And now just tighten the nuts and you should be good.
Mm-hmm. Hey man, this is not skiff friendly.
What do you mean? This is less than 45 millimeters. It fits the IntelliGel palette case, huh?
Yeah.
Yeah,
Yeah,
sure.
that's fine. I mean, it even fits in my in these 4MS pods.
So I will do the wedding, I'll call this so. Put the potentiometer knobs on.
Yeah, at first it was a bit. I didn't understand the filter, how it works, how the controls work together, and so it needed a couple of hours, and then it's really awesome, Tom. It can be very very smooth, can sound very smooth, and it can sound like you expect from MS-20 possibly, or I don't know, never played with one, but MS-10.
Yeah.
Really dirty and heavy. And it's cool. The gain knob is very Gaia.
A good
Very
tip
Gaia.
if you... Ganz geil, man.
Ja, ganz geil. Alles klar.
Yeah, a good tip if you really wanted to sound clean, put an amp after the output of the MS-20.
Yeah.
Yeah, so because it gets clean, but you can get it even cleaner if you because the gain is input gain, not output gain. And so if you have really low input gain and then give some extra gain at the output, because the output will be weak. If you have low input gain, then you can get an even cleaner sound. Steve up here is a great fan of that sound.
Yeah, that's what I noticed. When you turn the gain knob below 12 o'clock, then it really gets very silent.
Yeah.
And okay, now that clears it up.
So maybe I will do the final electrical tests.
Yeah, now before you power up a module, a good idea is always to check it for short circuits. What would you do, Tom? What's your hint?
Continuity test, but I already see that Andreas has selected that. I flip the module around and I measure between so the 10-pin connector, and it's 2 rows of the same. the outer 2 pins are -12 and +12, and the inner 3 pins are ground. So you can start testing your meter by touching the inner 3 contacts on the header, and it should beep. So that's normal. Beeps. Yeah. Now try between the inner 3 and the outer, and that shouldn't beep, or you have an issue. So that's looking good. And now try the other one. To make sure, now repeat the same thing, but swap around the red and the black probe. The reason why I do this is because sometimes you have diodes, and because the continuity test has a polarity, and you could have a short because of a diode, and if you don't check it both ways around, you could not. There's a chance you don't detect it.
Oh, okay. Good idea. Yeah, our module seems to be okay. So no short circuits. That's the main thing first to check. And then we could go over to the little 4MS case. Okay, let's bring the module underneath. So we have this Your Analoge Audio Design module, test 3, very good for DIYers.
I also have one, it's great.
Yeah, super handy for checking your stuff before you power it up.
So I can't see what it says, but
80 milliamps, which is about right. Okay. If you open everything up, it should go up to 100.
Yeah.
Yeah, that's looking a-okay.
So how would it look when we have a short circuit?
You would hear buzzing from your power supply. Well, at least it does here on my bench. I have an endorphins cargo control. By the way, a tip perhaps. Some people who already have quite a full case and plug in the MS-22 and they say, it gets noisy or strange stuff starts to happen. Keep in mind that MS-22 is quite power hungry, so about 100 milliamps on both rails. And in most of these cases, the strange stuff that people observe are a consequence of hitting the margin on their power supply. So so if that does happen, try unplugging a few other modules, and if that goes away, then it's your power supply that's not juicy enough. To be clear, it hasn't happened that much, but enough to see a pattern.
Yeah, sure. I mean, some of the modern modules, they are so big, so powerful, and they take so much power. To me, it's a bit like the power supplies didn't move so much forward than the modules. And most of the power supplies don't have so much power. Yeah, we already gave a couple of informations about how to power up your module, what to check. So at this point, maybe you experience magic smoke or it works, hopefully. Let's talk about the calibration thing a little bit, at least, Tom. I tried to follow your guide. And in my opinion, I must say, know the module, play with it, and then you can take care about the calibration, and then you know what to calibrate and how it should sound.
Yeah, that's a valid comment. It's
maybe you want to talk a little bit about the calibration.
Yeah, sure. So something that is not really perhaps explained in the calibration manual is the actual goal of the calibration. So the goal of the calibration is to make sure that the range of the front panel controls for the low pass and high pass filter, that they're useful so that the physical range of the knobs actually matches the useful musical range of the circuit that's inside. And so I've illustrated here the goal of the calibration. If the module is properly calibrated, then when the low pass knob is fully closed, it should fully attenuate a low bass note for, let's say, -30 or -40 dB. And then when it's fully open, you should hear everything up to 20 kilohertz. Same thing for the high pass filter. So when it's fully closed, fully lowest frequency, a bass note should get through without attenuating. And when it's fully open, you should hear the resonance peak when it's resonant of the high pass at the edge of what you can hear when you're filtering white noise. So that's perhaps still a bit abstract. And so how do you get there? And these are the front panel controls. And in between the front panel controls and the filter circuits of the low and the high pass filters, there's an offset trimmer and an attenuation trimmer. And so you should imagine this as a little offset and attenuation module in between the front panel and the actual filter circuit. And so think of, for example, the Befaco ABC module. You could do something similar with that module as we'll be doing here with the trimmers on the last two PCBs. So here, this is side view of the filter. On the bottom are the jacks here, and here are the trimmers. And the last board is the high pass filter. And so board D, the second to last board C, that's the low pass filter. And you'll see if you orient the module like this, the left trimmer is always the gain, low pass, high pass, and the right trimmer is always the offset. And for the gain, if you turn it counterclockwise, you reduce the gain or increase attenuation. If you turn it clockwise, you give more gain. For offset, counterclockwise is negative offset, clockwise is positive offset. Now, I will try to visualize a bit what this does. So, how do we look at the behavior of the filter?
Tom?
Yes?
Let me say one thing. We have a question here about the spread knob.
Yes.
Which should be the high pass frequency.
Yes, right? Sorry about that. So yeah,
we'll come back to this later. I would say let's clear up this first.
Yeah, because definitely.
First, I found it a bit irritating too that this is called spread and not. I mean, I think I get why, but at first it was a bit unclear.
Yeah, you're right. So the spread knob is the same thing as the high pass knob. It refers to the fact that when you link the filters, that knob becomes the spread of the two filters. So it defines the bandwidth of the band pass filter.
Yeah.
Does that clarify it?
I think so. I mean, you have to really understand what the high pass does and what the low pass does, because if you want to spread it, you always have normally the high pass filter below the low pass filter cutoff, right? And then you have these band pass between them. Means, for example, you have the high pass at 9 o'clock or something, and the low pass at, let's say, 3 o'clock. And then you have this band in between these two cutoff frequencies, which passes through. And that's your band pass. And if you link this by this first switch, then this becomes the spreading between these two.
Exactly.
Yeah. That's what I found out by doing then, but at first it was a bit strange to me too. But yeah.
Okay. So
yeah, it makes sense now, he says. Fine.
All right.
You can go on.
Moving on. So here on the left, you see a drawing of the calibration setup. So we put white noise into the filter, and then we will put the output on a spectrum analyzer. I'm also going to show this in a bit, how it responds. We put the low pass fully open, the high pass also fully open, gain, moderate setting, and resonance right before self-oscillation. And so then we will see at the low pass filter, if we tweak it, you will see the resonance peak. Well, before I discuss this, let me briefly say what the spectrum analysis is. So it's a plot that shows the intensity of signal coming in versus the frequency. And so typically on the left-hand side, you'll have the low frequencies, and on the right-hand side, you have higher frequencies. And in audio, a typical range is from 20 hertz up to 20 kilohertz, because that's the range that we can hear. And so the white noise, by nature, has a completely flat response if you plot it in a spectrum analyzer. And so if you put it in a filter and then look at the output in a spectrum analyzer, you're able to see the envelope of the Bode plot, also of the spectral behavior, the filtering behavior of the filter. So maybe I'm quickly going to swap to my spectrum analyzer here in Ableton Live, because I think it makes more sense that I briefly already show it to you now. Give me 1 minute to resize my window. I have two screens with dissimilar resolutions. Can you see the spectrum analyzer? Yeah, I think so. So this is noise going in. So now you should be able to hear the noise. And now my filter is fully open. And so the green stuff you're seeing, that's the input. And the yellow stuff that you're seeing is the actual MS-22 filter. So here you see me closing the low pass filter. Now it's fully closed. And now I'm opening it again. So now I'm going to move the high pass filter. Note that on the bottom, you don't see the resonance peak that much. And now the peak is moving upwards. And now I'm reaching the edge of the physical range of my knob. And you hear that the noise is at the edge of your hearing. Also interesting to note, and now I'm going to close the low pass a bit, high pass, and you see now I've created a band pass, but the filters are not linked yet. And so I'm going to change that. So now I'm moving the low pass knob, and because the filters are linked, both are moving together. And the effect of the resonance can be seen. I've increased the resonance now, and you see that there are higher peaks at the cutoff frequencies of the filter because of this. So when I completely turn down the resonance, these peaks disappear. When you go too high, of course, it begins to self-oscillate. And the reason why I'm turning up the resonance for calibration is because it allows me to clearly see where my cutoff frequencies are. So I'm going to hide the spectrum analyzer again for now. Just 1 minute. Okay. And I will continue with my explanation here. Okay, so you saw in the spectrum analyzer the behavior that I'm showing in this slide. So you can see the peak moving from left to right as you turn the knob. So what's the purpose of the gain trimmer? The gain actually allows you to control the range over which you can sweep the filter with the front panel knob. And so the idea is to map the useful range of the filter to our hearing to the physical range of the knob. You see if it goes from the lower end of what we can hear to the higher end of what we can hear, and that is mapped to the knob, that's perfect. So if this range is too small, you'll see that you would like that the range of the filter knob is on the front panel is actually bigger. So in that case, you have to apply more gain so that the range becomes wider. Same thing applies if you find that the range of your knob is, well, it stops being useful before you're at the physical end of the knob, and then you should reduce the gain. Offset is the other trimmer, and that allows us to center this behavior. And so when it's centered, the range is perfectly mapped between the filter useful range and the physical range of the knob. And you'll see that if it's too much negative, you'll move into the inaudible range. There's also an important note I need to make about this of quirky behavior in the high-pass filter, but I'll show that in a bit. And so you'll see that on the lower side, you'll have a portion of the knob that's not really useful. And on the higher end of the side, you'll wish that it would go farther. And so in that case, you need to apply positive offset. Same thing is true if you can't get low enough with your cutoff and have some useless range on the knob on the high end. In that case, you need to apply a negative offset. So one final note before we go back to the spectrum analyzer. This is something you've already seen in my short demonstration just now. And so because the filters are in series, we'll see their product. And so you see that normally this is the low pass and this is the high pass. And together you'll see that they look a bit like this. And so you do have to imagine where the high pass and the low pass are located based off this combined envelope that we're seeing. So here's a general approach towards calibrating your unit. This is the basic idea of how to calibrate, and I'm going to touch upon a few quirky things when we move back to the spectrum analyzer after this. And so when you start with the low-pass filter normally. Sweep the knob, then you will see what the range is. Is it too wide? So do you have the sense that it's too wide? Then reduce the gain until you can actually see that it's too small. And so then you will get a sense of where the center of your range is of the low-pass filter. Then it's time to apply offset until it is centered. And then you repeat, you apply some more gain until you get the range just right, tweaking gain and offset. And then next you move on to the high pass filter and you apply the same principle. Now I will point out a few things again on the spec. There's one particular quirk with the high pass filter. So it is possible that if everything is open, when you first start your module, and you apply maximum gain, and you will see that the output is still weak. It will look a bit like this. So you're measuring your noise at minus 70 dB, whatever, it's really too silent. That's a bit of quirky behavior that happens when the high-pass filter gets too low of a cutoff. You can then solve that issue by turning the high-pass filter up, and you should see that it reaches a decent level. And then if you turn it further, it will start to act as a high-pass filter. And this is behavior that you need to remove with the offset and the trimmers. But when you start the calibration, just turn the high pass up until it's completely flat and do the low pass filter first. And so I'm not calibrating my module now. I'm using a calibrated module to fake what it should look like. So for example, if this is a new module, not calibrated, I'm now starting to turn the knob of my low-pass filter. Nothing is happening, and now I see the peak. So I have some useless range, a range that's too much on the high side. And now I'm not at the physical end of the knob yet, but I can still keep on turning, nothing happens. That means that on the low side, the range is also too high. And so now at this point, I will reduce the gain a little bit. As a result, you'll see that when it comes close to being useful, you'll see it move up a little bit again, as it does now.
Yeah.
Then you stop and you check the range again. And then it might be that it's not centered, and you get closer. It's an iterative process where you move closer to the ideal. And of course, as Manu said, you can perfectly do this by ear. The reason why I've added this is because I'm an engineer and a nerd. And I thought that people,
and it's
think
good
this
to
is
see
interesting to learn.
Then you see where you are. It's good.
Yeah, it helps a lot that in this format I'm able to comment on the behavior of the filter as I go. Then what's also important and fun to show, I'm going to so now you're seeing a saw wave coming in, and if you sweep with resonance, you can see and hear the filter picking at the harmonics. And you see what's important to note, why the saw wave is interesting, is that now it's better than noise to see how much it attenuates for a low note. So I can see the original coming in is minus 10 dB. It goes down to minus 30, so I have a difference of minus 20, which is okay. The same thing goes, what's also useful to check with the saw wave, when you're moving the high pass, it should, I hope you can see this, but as I move the high pass up, the resonance will boost the harmonic of the saw beyond its original amplitude. And so that's also one of the nice things you can do with such a filter. You can use the high pass to boost your lows. And then it moves on to the higher harmonics. All right. So that kind of... that's also still an important note I need to make. If you truly get lost with the calibration, you can measure the resistances of the trimmers and use a multimeter while measuring the resistance of these trimmers and set them to these values. These values, I've measured 10 modules in the past, and these are the averages of the calibrated values. So if you're truly lost, using a multimeter and setting the trimmers to these values should give you a decent result, even or a decent starting point. And then, yeah, that's it.
Yeah, Tom, thanks a lot.
Yeah, my pleasure. And also thank you guys for giving me the opportunity to actually explaining this decently for once. Instead of this perhaps saves me a bit of time to write the update to the manual, and perhaps I can still put it off for a little bit.
Yeah, Tom, thanks very much. This was super good. Thanks to the participants. I hope you enjoyed it. I hope your modules are running. If not, possibly we should end the official part of the video now. What should I play? The filter? Yeah, here's our filter. What I find really interesting is this vocal sound like type of sound. That's super interesting.
Yeah, when you link it, you have these two resonance peaks, and that gives the beginning of the idea of a vocal resonance.
Yeah, right.
So when you have these vocal resonators, it's typically 3 or 4 of these resonance peaks sweeping together.
Thanks so much for the filter, for joining the workshop. And yeah, bye-bye. We're still in the chat after we stopped here. So if anybody has questions, and you can reach us by email. You also have Tom's email.
Yes.
Yeah. So officially, thank you.
Bye-bye. Talk to you guys later.
Thanks, Tom.
Ciao. Bye-bye.
Ciao.